everyone. So I decided to solve uh, all the Kickstart problems. So I think I have solved this one somehow. I guess they are not showing my submission. I'll check. So I have solved this one too, and got a V on it. So I was doing something wrong. I didn't check. So basically, the question is about given two workers and there are n shifts. So they can choose to work on one shift independent of each other. Now we have to count the number of ways such that uh, given a configuration that some guy worked on that shift or some guy didn't work on that shift, uh, the total happiness should be greater than h. So we can think of it as let's say if n is equal to 3, then A has its own way of doing the shifts. A can choose to work on only first shift, second shift, third shift, first, second shift, second, third, first, third, one to third, and B also. But we need to make sure, given any configuration, they should at least, matlab, there should not be any one day that none of them work. So here is the formal definition. So two words will be for ith shift. Ananda will gain AI points if he works, while he will get BI points if she works. Both will be happy if they at least receive H, but there is also one condition. During each shift, at least one of two guys has to work. So idea was to create a subset. Let's say this is a subset for n equal to 5. Let's say this is the subset for A, which means uh, let this be 0 and next one day. So at 0th day, A worked, but at B it didn't work. Sorry, it worked on these 3 days. Now, what are the possible configuration that we can do? Uh, Definitely, it can work on these days. So this is a minimal subset at which B should work. So this should belong to B, and all its supersets also should belong to B. Because if we'll take the OR of these guys, then it should be 1. It should be 1 so one such combination, so we'll try to enumerate these pairs. This is for A and this is for B. So we'll try to have our counting in this manner. For every subset of A, we'll count all the supersets of this guy. In general, if it has a bit set of this, then let's say the n is we can create a number such that all of its guys are n. This length is n. This should be equal to n plus 1 minus 1. This will give us the all ones minus 1, and then we can XOR it with this bit set at the left. We'll get some bit set, and we need to create all the supersets of it. That is the claim. So if this is the guy, we can XOR. No, actually this is wrong. There is no point of XORing it. So I think we should do this. Correct, I feel that was correct. So here in this case, this is what we'll get after XORing. It will 1 1 1 1. Only this guy will be 1 and everything will be 0. And then we need to create all the supersets of this. How to create supersets? We can think of it as, let's say there are many zeros. They can, so whenever there is a 1, we cannot do anything with it. But if there are zeros, we can change it to a 0 or a 1. So there are 1 2 3 4 zeros, hence we can create 16 supersets. To create a few, I'll try to create with these 3 zeros. First is this only, second is this, third is this, fourth is this, these are the rest 8s, and these are the 16. So my claim is that for this configuration of A, we can choose the 16 subsets, supersets. Now what we should do, we should check the happiness for this guy, like we should sum only for A of 1. So A array is given here, right? We should check, okay, what is the answer at this day. It should be greater than equal to hi, and this should also be equal to hi. So we need to filter out these guys. We are only interested in those guys whose summation is greater than hi, and that's a +1 for us. If we'll do this naively, then it is pretty much the problem for every subset. Count all its supersets. And again, there is a log n factor to sum. I think we can remove the log n factor because we can do that. We can pre-compute that, but this we can't remove. This is a very generic problem of matlab there will be 3 to the power n different configurations. So for first test case, I think it will work, which is 505, but for 28 watt, it is beyond that. So we should use source TP. Idea behind source TP is we can do the same thing in n log n. Here it's 2 raised to the power n into n. So let's try to code it up. Actually, source TP is over subsets, but here we are dealing with supersets. If we know the fundamentals of source TP, then we can easily extend the idea to supersets. They are same only. So I'll try to code it simple. I've already coded it some, but it was a source repeater giving me wrong answer. So I'll try to discard this and write a new DB. Simple as it is. Okay. This is just to print binary representation. These are just taking the input of A and B, and here for every subset of A we are this is for every, okay, this is A1, we don't need this. For every subset of A we are checking whether this leads to a good value or not. If it is, then okay, we should do a map. Okay. Actually the size of DP was Let us also do the same thing for B, shall we? So this was some A, this is some B. So we have created this. So now the only thing remaining, so now let's our answer be answer. Then what we should do for every subset of A, for every subset basically, for this a subset, uh, if MA of I is equal to 0, we can just continue because A cannot take this position. But if A can, then we should find all the supersets of then let's say our DP should be solved for all the supersets. So okay, so first, since there are only n bits, so we should create a number such that all its starting n bits are 1. Let's create it as here long all ones is equal to n plus 1 minus 1. So if n is equal to say 2, we should ideally be getting this number. What is this? This is 2, this is a 3 minus 1. This should not be there. So all ones, we should mask this guy all ones XOR to I. This is a number, so we should do that mask. Then this bit should be nth. I'll tell what this TP is. This normal subset TP. So what so this is all. Here is mask and here is the bit. The main motive of this TP is so we'll need to count all supersets for prefix of length equal to bit for mask. This is the VDP. So we'll try to, okay, let's write it there. Okay, so if bit is equal to -1, then that means we need to remove only the occurrences of B, which was easier. This is the base case of the DP. Else we need to do something else. Else if mask's beard bit is on, then its superset will also be on. We can't do much about it, so we'll just remove. We'll try to only find the supersets of bit -1 prefixes. Else there are two ways to form it. One is this only. Another is to off the ith bit. So in order to off this ith bit, what we can do is we can do this operation and we can delegate the answer of bit -1. We can realize the fact that at any point bit we are either delegating any TP state, either delegating it to -1, hence this base case will be fruitful, or we are making our mask more higher, or we are depending on a higher mask state, which is fine. Anyway, we are doing this, so eventually we'll reach this. So both the biggest I think have been taken care of, and then I feel like that's it. We'll add the memorization if this works. We will debug more. think already test cases are there. This is passing. We are not sure whether it will pass or not for higher cases. So let's try to build a case ourselves. So let happiness be, so let there are three ways, and let happiness is equal to 1. So let's round all subsets. That means the answer should be equal to, basically every subset is an answer. I think there are many ways actually. So for this cannot happen because A is not working here. This is false. No, actually that can happen if only B will work. So that's a, so its count is XOR is this, and there is only one superset. That's a +1. I feel like here a 1 should be there. So let's find an answer first. Then we'll. I think it is fine. Here what we can do is, for this subset, let's try to find corresponding this. So yeah, I guess there are two ways. Again, there are two ways. Here I think only there should be 4 ways. I feel. I think number of ways should be power of 1s. So 2 here, 4 here, 4 here, and 8 here maybe. So this is 12, 16, 18, 22, 22, and 5 is 27. Okay. 27 is 3 raised to the power 3, which should be the answer by the way. I don't think I'm missing anything by the way. Maybe I'm missing something. I think this is not true, and this won't be the case. If this is 0, then this will be the case. I think then it is 27. Okay, if this is 1, then this won't get count because we are not choosing anything here, and there will be one super and then one should also be there. We are taking out supersets of B. This also won't count maybe. Here in this case this will be 7 because there will be B whose split would be 1. I think this is correct. Let's add DP to it now. This should be straightforward. It's just normal counting. Will work just fine. N is large equal to 21, let's say. You can add -1 over here. This is size of DP. And if DP of bit mask is not equal to -1, then we can just return it. Else, अरे यार, something got break. Something broke here. Okay, got it. I hope it should be correct. Okay, this got completed. So I'll try to rephrase the idea. So basically, you need to count all the subsets and then the supersets of those subsets such that for A the happiness should be h greater than h and for B it should be there. You so we try to independently calculate it for A and B. Then for every subset of A we try to find all the supersets such that both have happy. That's a normal SOS-DB problem. For more links you can visit this article. That's how I learned the SOS-DB. I stumbled my head around 3-4 days to get the idea and then it was all good. I then solved 3-4 problems and it was great. That was the only requirement for this. It has a prerequisite like basic DB and label masks. That should be fine. Thank you.